Welcome back to Teaching Statistical Thinking. In our last video, we talked about describing a distribution using number summaries, and we focused on measures of the center of the distribution, the mean and the median, and we also talked about the mode. Today we'll be talking about number summaries for a single variable, but we'll be talking about numbers that describe the spread of the distribution, or how variable the numbers are in our data. Again, I'll be using the 4 variables that we made up in the last 2 videos, and then move to our real data set with the movies. So let's go. The simplest measure of variability is called the range. The range is simply the maximum value minus the minimum value. So for variable 1, it was simply 7 minus 3, which is 4. For our second variable, 9 minus 1 is 8. For the third variable, 9 minus 1 is 8. And for variable 4, it's 10 minus 4, or 6. So by this measure of variability, variable 2 and 3 have the largest spread. A second measure of spread is called the interquartile range. I abbreviate it with IQR. Interquartile range. And just like it sounds, it's the 75th percentile minus the 25th percentile. For our first variable, the 75th percentile was 6, the 25th percentile was 4, giving us an interquartile range of 2. For variable 2, the 75th was 7.5, the 25th was 2.5, and so the interquartile range is 5. For variable 3, the 75th is 9, the 25th is 1, so our interquartile range is 8. And for our last variable, the 75th was 5.5, the 25th was 4, so the interquartile range is 1.5. Here, for the interquartile range, the spread in the middle 50% of the data is greatest for variable 3, and the smallest for variable 4. Now the last measure of spread is called the standard deviation. And I'll abbreviate it SD. The SD, think of it as the average distance to the mean. So to calculate it, we simply take each observation minus the mean, we square it, then take the average. So let's do this for variable 4. The mean for variable 4 was equal to 5. So we've got 4 minus 5 squared plus 4 minus 5 squared plus 4 minus 5 squared plus 4 minus 5 squared, 1, 2, 3, 4, plus 4 minus 5 squared plus 4 minus 5 squared plus 5 minus 5 squared plus 6 minus 5 squared plus 10 minus 5 squared. Okay. Adding those up, it's 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 0 plus 1 plus 25. That's the sum of the distances. Adding them up is 32. Dividing by the number of observations is 32 over 9. And now we're in squared units, so we need to take the square root. And that gives us a standard deviation of 1.9. Writing that more generically, think of it, we're summing from I equal 1 to n. Each of our observations squared, dividing by the sample size, and then taking the square root to get back to our original units. So our standard deviation for variable 4 was 1.9. Now I won't calculate the standard deviations for variable 1, 2, and 3, but I encourage you to do that on your own. They are 1.2, 2.6, 3.8, and 1.9. Notice in those standard deviations, for variable 3, we get the largest standard deviation. This was the histogram that was U-shaped, so most of the observations were far from the mean. What makes a large standard deviation is when the observations are far from the mean. What makes the standard deviation small is when the observations are clustered closely to the mean, as in variable 1. Now that you know how to calculate the standard deviation, let's talk about it for the budget of our movies data set. The average budget was $53.5 million. So to calculate the standard deviation, just as we did here, you would take each budget minus 53.5, square it, sum it up, divide by the number of observations, and then take the square root. When you do that, you get the standard deviation of budget is equal to 49. Our mean was 53, but on average, the data points are 49 away from the mean. Again, for our genre, that is our categorical variable, okay, it makes no sense to do these sort of mathematical calculations on categories, so we don't use the standard deviation for categorical variables. What I want you to do before the next video is practice opening up some data sets from Dazzle or from JUMP and calculating the range, the interquartile range, and the standard deviation. See you next time.